Welcome to Definitely Maybe Agile, the podcast where Peter Maddison and Dave Sharrock discuss the complexities of adopting new ways of working at scale. Hello, and I'm here with Dave and Callum, and we're going to have another interesting conversation, I hope. So I'm going to start this off today with our special guest, Callum Sharrock, who's going to talk to us about his journey, some of the things he's been doing, which are really interesting around AI and robotics. And so, Callum, why don't you go ahead and tell us a little bit about your journey?
My name's Callum, and I studied computer science at the University of Toronto and have been kind of working in the robotics and AI space. Specifically, I previously worked at Tesla, designing their cleaning robot for the Robotaxi program. And then more recently, kind of have been focusing on AI, specifically looking at safety evaluations for AI in the real world. And I'm currently doing that at Andon Labs.
Okay, awesome. So what took you down that path? Why did you switch from the Tesla path to the AI safety and evaluations type thing?
Yeah, so I think I was fortunate enough to basically after graduating, I took a few months and had enough kind of resources to basically figure out what I wanted to do. And I spent the time kind of thinking and doing a bunch of research and basically figuring out okay, cool, if I spend X amount of time every single day doing something, I want to make sure I'm doing something that I broadly agree with. I think it's quite funny how a lot of people don't spend that much time thinking about what they actually want to do and just kind of spend the time doing things that they think they should do. So I took the time, kind of decided what I wanted to do, and basically stumbled upon the whole safety thing regarding AI, and specifically think safety with respect to AI is kind of under discussed. I think it was surprising to me how little emphasis I had regarding the safety aspect in my academic upbringing. And then kind of the more and more I thought about it, I thought that A, not enough people are really looking into it. And then B, I think it's a area that is quite fun to look into because you basically get to make frontier systems that have never been made before and then basically analyze them for oh, what are all the ways this could go wrong, such that when they inevitably do get deployed, we can kind of have some sort of confidence that they're deployed in a safe manner.
Can you expand a little bit on the robotics piece? Because what you've just described there is evals and safety, but you've got quite a history with working with robotics as well, and then just a little bit about how you brought those two together.
Yeah, for sure. So in high school, I was in a program that kind of let me skip half of my classes and spend the time fiddling with electronics and robotics instead. So I made anything from video games to basic electronic circuits for physics classes and stuff like this. And I really liked robots and I really liked kind of the hardware side of things, making something that's just not just on my screen, but deployed and interacting with things in the real world. And then I didn't do any research on university programs. I accidentally went into computer science instead of engineering. And then I was in computer science doing a lot of theory and wow, this isn't a robot at all. And then I kind of was pretty fortunate because at the same time that I'm sitting in these computer science classes being I wish I could play with robots, it's becoming pretty popular to do reinforcement learning and all these AI methods specifically on the robotics case, and basically gave myself an ultimatum to only ever look at internships that have robotics. So I spent my first internship, I was at a company out in Berlin, and we did quality assurance detection. So we used deep neural networks to basically do welding defect detection. So it's just a normal classification method, which is pretty old at this point. But I got to work with robots, and I did machine learning to make the robots basically work better. And when the robot said it welded a door, we had very high confidence it had welded the door. And then after that, I worked and did painting robots. So basically, anyone who drew something online, we could use a robot to repaint it with actual acrylic on canvas. And then from there, went to Tesla, did their cleaning robots, worked a little bit on Autopilot and Optimus regarding their cameras. And then I did some research at the Vector Institute in my final year, specifically on reinforcement learning for compute-constrained robots. So basically, how can we make low compute robots work a little bit faster and a little bit more effective?
Which was your favorite out of all of those? Must be good experiences.
Yeah, I think my favorite one right now is actually my favorite one is the one I'm doing right now. And it's basically because with all the robotic stuff, I realized that what I basically like doing is stuff that's deployed and interacting with people and things in the real world. Because I think it's very easy to get very theoretical and think about all these edge cases. But to some degree, it doesn't really matter if it doesn't happen in the real world. And there's a bunch of things that happen in the real world which you just can't simulate no matter what you do. So what we do right now is basically like figure out different ways that we can deploy AI systems, and then we can evaluate how they work in the real world in as safe a setting as possible, and basically like report these risks to the general public, to give like A, transparency on timelines regarding kind of AI capabilities, but also B, show the different like safety concerns that are related.
So what do you wish that people who didn't exist in that AI ecosystem you're inside of and are sitting outside of it and just sort of have access to these tools that they type all this information into, what do you wish they understood?
I think one of the things that honestly like took me a little bit of time to realize is, I think it's called Moravec's paradox, which is basically like it's like an amalgamation of we can do more, we can do less in a year than we think, and we can do way more in 10 years than we think, or any time span that you want. And like I think this one for me was like, oh, a lot of people kind of will use whatever AI assistant that they have, and like, oh my goodness, it got this one easy piece of code wrong that I could definitely get right. And like this is probably true. But I think one of the really interesting points is like if you look at the trend line, like 3 years ago, ChatGPT was quite bad in some ways, and like ChatGPT today is actually quite good at many things. And like the new Gemini models are solving IMO problems, and there are different models that are like discovering undiscovered math and like all these things. So like the trend line is actually phenomenally large, and I think a lot of people like take a current snapshot and say like, oh, yeah, it's not going to change things that change the way things are happening because look at this one use case. But if you actually like connect the dots, it's been about for not that many years, and if you look at the like trajectory and slope, it's I think quite interesting.
I mean, when you're looking at that, there's a classic change problem there, which is exactly when when I threaten to change your work environment by bringing new technology in, the immediate response is to go and look for all the places where it can't do what I'm doing, which is exactly what you described. We're going to go and look at that one case which didn't work, and this didn't work, and that didn't. Have you seen really successful examples where you can flip that on its head, for example, and focus on things where it really excels and start shifting that mindset?
I think partially, like I think this is partially why I'm excited about the work that I'm currently doing, because what we do, or the way we look at what we do, is that we do these evaluation in the real world. And the most famous one is like this vending machine example where we had the vending machine, we gave the opportunity to run the vending machine, so it decides what to stock, how much to sell it for, and talks to people over Slack. And we've been doing this for like quite a while now. And the funny thing is, like, you can kind of check as model releases come out, the different capabilities and how much money they're able to make, and the different ways that you can jailbreak them to get free things. And it's like one way of looking at it is like, oh, I can still break the vending machine that we have currently with this one novel way. But if you think of overall how much better they become over the time, it's like quite a steep trend line. And I think just like trend lines over many years instead of looking at like a snapshot of like these are the things that it's not doing now. And there's a bunch of these trend lines. So there's the very famous one in the community is basically like a meter graph, which is what's the time horizon over which AI is able to complete a coding task. And like we've quickly seen it go from like a few minutes to a few hours. And if like any sort of line continues, and like the interesting thing is like it's not linear, it's like exponential, which is kind of like obviously like similar to the COVID thing, like quite a hard thing for people to understand. But like I think in many domains we see like exponential increases in capabilities for these sorts of things, and in simultaneous ways we have like these things helping us make better scaffolds to make these things even better. So there's like a recursive self-improvement aspect to this as well, which is true to some degree on like the model side and the model performance and training side, but also very much true regarding all the scaffolds and all of these.
And robotics is almost a natural break on that, just because robotics is in the physical world. It's got to do a whole bunch of things that pure digital solutions do not have to worry about. So do you see that the trend is the same, but it's a little bit slower, or do you actually see that it's pretty much mirroring the development in the large language model?
Like I think the common phrase in robotics is that robotics hasn't had its like ChatGPT moment, which I think is like relatively true. I think my like unpopular opinion on this is that robotics is a software problem at this point, not a hardware problem. And my kind of like proof on this is the fact that if you teleoperate a robot, you can make it do basically anything you want, which to me indicates that like, yes, there's like some problems about like overheating or whatever, but like you can basically get a robot to do anything you want. It is just like an algorithm problem. And I think one of the things that is like, I guess maybe not taking that much into account from the things that I've read is the fact that like as AI gets better, these algorithm problems are going to become like relatively easier. So while it is true that there's definitely like a feedback loop problem, and I think like the better example of this is like biology and experiments, where like a biology experiment might take like 3 months or even longer to get feedback on, whereas software is basically instant and robotics is somewhere in between. I think the improvement of software is going to improve all of the other physical processes as well.
There's a lot of learning going on there. And I mean, if you look at even things like the Chinese robots as they're advancing at a rapid rate, their New Year's show, for example, when you just compare one video from one year to the next, as they've greatly achieved all sorts of fantastic things. At least that's how much of that is marketing and how much of that is true. I mean, it's always interesting to see, but they do seem to be coming along leaps and bounds. For sure.
Literally leaps and bounds.
Literally, yes. Backflips too.
It's quite unnerving watching some of those things now. There's sort of before and after, or this year and last year. Yeah, I mean the change is remarkable.
One of the pieces there, of course, is that so what point, Cam, do you think that AI will entirely replace, we'll pick something like developers simply because developers are probably the area that the most investment has gone into in looking at how can we get AI to code. But how fast do you think we're going to start to see the shift occur?
Yeah, I think it's like a very interesting question and like a very hard one to answer. And I think one initial pushback I'd have is like, I don't think it's like entirely fair to say that like coding or developing is like, oh, it's where the most investment has been. I think this is like partially true, but I think also partially programming is like a very verifiable domain, which means these feedback loops are like relatively clean and relatively easy. And we can think about like accounting as like a very similar thing, or doing taxes, or like mathematics for that example, where it's like basically logic, A implies B implies C type of thing. So therefore like they're relatively easy to validate. And I think in that sense, like all the big technology companies are bringing up a bunch of statistics regarding like Anthropic says 90% plus, or if not all of its code is basically written by AI. And then Google says that about 50%, I believe, of its code is written by AI, and like all these things. And I think like these trends will continue and increase. I think the question mark is like, what does this mean for developers? And I guess like personally, I don't write as much code as I used to. I'm more so like figuring out basically how can I like validate the code and provide feedback on code that is generated for me. So I think like, I guess to answer the question is like, I think we're going to see more and more percentage of developers' code being written by AI. I think the question that is kind of unanswered or is hard to predict is like, does this mean that developers are more leveraged and therefore are able to provide more? And like, is this going to increase demand for developers because they can do so much more? Or does this mean that like, oh, we don't need developers anymore and therefore they're going to be out of jobs? I think this was like, I've heard compelling arguments from both sides of the debate. And I think it's like very hard to say whether like, oh, we'll have more developers, but I think basically like more code is going to be written. And
I always find it, Peter, I'd love to get your insight on this one as well. But the thing that strikes me there is it's the classic consulting argument of it depends, because there is code bases that really you can probably just point various tools at and go and just rebuild those. But there are lots of problems where you still have the kind of the cognitive experience of being able to try and figure out where things are going, and just a whole bunch of ideas of how you're going to retool. And we've talked about this, Peter. The retooling of an industry isn't just software delivery life cycle done really, really quickly. It's like, why do you even need that? Maybe we've got to rethink how we think about the firm.
Yeah, the entire changing of the roles. Where do those roles then go? What functions do you need surrounding the creation of the piece of software to ensure that it's actually getting the outcomes you're expecting, and it's doing the bits that you need it to do, and it's doing it to a quality that you require, and how much of that is baked into the system. And we're not there yet, for sure. Like these agents still have a ways to go, but they are, exactly to your point, Callum, they're accelerating at such a rate that you can see it happening.
Yeah. And I think if more of like a concrete answer to your question is like, I can't speak about like the industry as a whole. I think for myself personally, in my career trajectory, I'm not focusing on learning frameworks or tools or programming languages. I'm more so worried about and trying to like specialize in how can I basically apply any tool that exists to problems and get feedback and iterate and like basically like solve the problem instead of like understand the technical. And then I pick up the technical when and where I need to. But I'm not going to like go and learn C, for example, at like an intermediate level.
Yeah, I think the language becomes a lot less important when you've got a system that can effectively translate it into whatever languages you need. It does vary a little when you've already got an existing code base that you now need to operate against. And if it's in some esoteric language that you don't have as much training in the model on, then it becomes, your answers aren't necessarily as good. You also run into situations where, well, you go to the person running the mainframe and you show them, look, you could write all this stuff so much quicker. And they look at you, well, I don't need to. so there's that side of it too. It's like they don't see they don't see or feel the demand at this point, which is just the nature of where they sit in an organization and the way that they do things. So there are all of those types of edge cases, but to your earlier point, Callum, they are somewhat edge cases for the vast majority of the work.
I think like a simple is the fact that like Excel was rewritten in complete Rust and Python over a short-ish amount of time from the original code base, which like I think you can take whichever learning you want away from this, but I think like transferring code bases is as far as problems go actually not that difficult because you can basically generate a bunch of tests to figure out how the current code base works, and then you can generate a new code base, and as long as the same tests pass and the tests are comprehensive, you're kind of good to go. So I think like actually the really important thing or like the really interesting thing is the fact that like validation and testing are so much more important because at least in my development experience, it's like basically the only thing that I do, which is like with how can I test that it works for all the use cases that I have.
Yeah, I'd agree. And I mean, with the systems that I'm building, I'm doing exactly the same thing. It's like I'm not really looking at the code. I'm hearing that from a lot of people who are out building systems. It's like not really caring or looking at the code that much. It's more about validating that the outcome that you get is the outcome that you're expecting, and especially based off whatever your intent was.
Well, it gets quite interesting because now you can look at the behavior of the system under duress and explore the edge cases much more easily, whereas before it was some poor soul who had to validate everything manually and then somehow find time to do smoke testing when nobody was putting them under pressure.
Yeah, that's actually an interesting point there, in that we've developers very much had the problem previously of getting shitty requirements that made absolutely no sense, that they then had to somehow figure out, and then they would build the wrong thing and deliver it. Whereas it's kind of funny how what I've seen with a lot of developers is they're actually building and creating the context now. So they've kind of, because you've not been giving us all this information for all of these decades that we've asked you for again and again and again, that we need to define what it is we're going to build. Now we've got tools, we can start to build that. So they're almost doing more work to create the architectural definitions and requirement definitions they need from what's coming in to be able to more accurately build the system going out, because a lot of that's almost required for the agents to build the right thing. It's kind of interesting, I find.
I've got a metaphor going through my head, Callum, of just how instead of, and I'm thinking racing cars and Formula One and things like this, where the way you describe the work that you're doing, you're much more in the cockpit trying to figure out how to navigate the race track, but you're not worried about how the car itself works. Whereas in the past, maybe there was more building of the car and less worrying about the road ahead of you.
Yeah, I think that kind of makes sense in the sense that like it's basically like an abstraction layer on top of something that has already existed. And I think like one of the things I hear a lot is like, oh, this is the same thing as like moving from C or C++, which is like a low-level programming language or something like Python, which like for all intents and purposes is like writing in plain English, which is that like if you write in Python, you don't need to worry about like how the computer works to that much of a degree, because especially for like quick MVP prototypes, you don't need to worry about like how the computer stores memory and does all these things. You kind of Python does it good enough for most cases. And like, I don't know, it's very hard to predict when and where there is a use case for a lower level programming language, or like when and where a Formula One driver needs to know how the car works such that they can give better feedback. Like, I think that's I think that's a very important part of the current iteration loop, is like actually knowing a little bit, like a few levels into the abstraction allows you to provide feedback, because you can kind of, I guess, like ideate as to why the problems are bubbling up the way that they are, which might be a little bit harder if you don't have that much understanding, I think it's like quite hard to understand like how long that will be the case for.
And I wonder at what point, if we stop caring about the language, at what point do we just let it go write it in assembler and we'll be fine, right? Because then if we don't need to read it, then why not write it in a faster language? Perhaps. The one of the other questions there was around like what are the big challenges you see that are preventing AI and robotics moving forward today?
Yeah, I think like a big one here is kind of like reliability to some degree. And I think like I struggle with this one because like I kind of like assume that people are just 100% correct. I like to think that when I go to the doctor and the doctor tells me something, like they know exactly what they're talking about and they don't make a mistake ever. And I think that like my classic example on this one regarding kind of like a slower adoption of AI is kind of like Robotaxi and Waymo and all these like autonomous driving vehicles, because we kind of like look at them and we go, okay, so in 2008, 2009, we had cars that are doing like 100,000 kilometers, like 100 kilometers through a DARPA challenge on the roads autonomously, and like the technology is kind of there, neat. And it's taken like 10 to 20 years to get it to a point where it's like semi-deployed now. And like this whole time has basically been, and I'm completely oversimplifying, but it's like it's been improving reliability around these systems to a degree where we like trust them to be implemented in ways that we kind of are happy with as a society. And I think like you could say something quite similar where like, oh, I think we can probably say that for, I don't know, like a weekend project, just like spinning up a few instances of like hot code will get you something that you're like relatively happy with, and the reliability is like good enough for what you want. But for example, if my bank has like done something over the weekend that is now in charge of my savings account, I would probably want like a little bit more validation, and I would want to know there's bigger reliability. So I think like one of the big ones is like reliability. How can we basically like impress upon the society as a whole that the systems that are being built are reliable? And then also kind of the second edge of this is like how can we create validation methods to like ensure reliability in some sort of like robust manner. So I think that's definitely one of them. Yeah, like I think that's kind of the biggest one I'll talk about. And it's like basically the same for robotics, just maybe a little bit further down the line, in the sense that like there's a generalization problem with robotics, in the sense that with the new models, we can probably create something that, for example, can go and run an espresso machine for a day-ish with some intervention, but not massive intervention. But getting this, like this espresso machine robot will need some work to do something like laundry folding. Like it's not like the exact same robot model. It's the same robot model that has been trained on different tasks. So that training process is a little bit like task specific, which is a pretty big bottleneck. And then within that specific task, the reliability side, I wouldn't say necessarily yet is where you can basically close your eyes and never have to worry about it again. There's still a little bit of like saving in edge cases, which you see with like Waymo and Robotaxi and all these guys. Occasionally it'll spin off to like some sort of human operator. And this count is kind of what people are tracking and looking at the timelines for.
So there's an element there of, I was just thinking when you were describing the reliability conversation around autonomous driving in cars, there's a secondary piece, which is that sort of societal move to understand that when a machine is running a car, for example, when the car is self-driving, there are consequences of that safety risk profile. Because if my understanding is already the cars are safer than being driven by a human being. And yet, as a society, our legal systems, our expectations, all of these things, when we think about what that means, is we're not ready to allow these safer than a human being driving a car vehicles onto the road, not because they're not safe, but because we're not ready for what that means for us. I'm just thinking, I'm going to assume the legal side is one particular piece, but insurance and a bunch of other things, what we can expect, which is less of a technology problem and much more of a social sciences / philosophy / legal challenge.
I think that's one part of it. I think the other part that's like super interesting to consider is the fact that like it's not obvious that we should be designing the systems to work in the infrastructure that we currently have, right? Like I think that world in which we basically have, we have this highway only for autonomous vehicles, and they do something else that are protected, and we can like minimize the sort of like unknown risks. And like in this case, we can also increase safety measures, and I think you can do the exact with AI systems that we can allow them to be deployed earlier, which is basically like understanding, A, can we adapt the environment in some sort of way to mitigate the risks and mitigate the unknowns? And the other one is like, I think this is like a lot of what we try to do is basically like we deploy them in these safe environments where basically if they fail, it's great, and we can report back this data to the people who need to see it. And if it works, it's also great because it works. And then we can inform the public regarding the kind of advancements and the trajectory of advancement of this technology.
Do you see problems where some of the trust gets undermined because people are applying these non-deterministic models to deterministic problems? Like where, for example, and this is I hope nobody's daft enough to do this, but something like where, well, I've got the model that's controlling the car and orchestrating the different pieces, which talks to another model that presses the brake on the car, but it decides whether it's going to press the brake on the car. I never want it to non-deterministically think, well, I know it's saying I should, but I don't feel like it today. I'm having my coffee break. I'm not going to bother. Oh, or for some reason it's given a set of instructions that it doesn't interpret in the right way, so it doesn't respond in the way that it's supposed to. Whereas if you had a pure deterministic system that basically says, I was told to press the brake, then you wouldn't have that problem in between the two. And because I do see this issue in some of the stuff I do, where it's like people just try and sprinkle AI on absolutely everything. And some of these things are, if I push a button to deploy something to that site, it's deterministic. I want this file to be copied from place A to place B. I don't need an LLM in the middle of that to do that. I need a system that copies bytes from point A to point B. It's at such a low level, I don't like having an LLM involved in that is a cost and an expensive one that isn't necessarily going to help me. It's just I'm consuming credits I don't need to.
Yeah, I think it's like a very interesting question in the sense that like I think there's like two parts to it. Like one of them is like I remember I saw a project and someone used an LLM to figure out what date it was, and like the date could come in 5 formats, and it's like quite standard to parse the date. And this is just like, but I think like my counter to this one is kind of like two things, which is like I think you were just like focusing on the wrong abstraction level. Like I think if you have a Waymo and you have an algorithm like you have an algorithm that's deciding how to drive the car. Like I think the correct thing to do is have the controls be basically deterministic, and then have a non-deterministic model like doing the orchestration. And like this is my argument. Like this is what humans do. And going back to the doctor argument, like yes, they're non-deterministic, but I think like humans make mistakes. There's a very high likelihood that they already are or soon will be making less mistakes than humans are, and therefore I could see soon the perception shifting in the same way that it has for like Go and chess, which is that like I would at some point rather have most drivers on the road be done by AI because they're just like significantly safer than human driving. Because I think like the stats are already like orders of magnitude safer for autonomous vehicles than they are for the other ones, and I think like everything in between is to some degree like small technical edge cases, which definitely should be worked on, and or like the publicity and marketing thing, which is like I think society is rightfully cautious to change. It will change at the end of the day. And I think this goes into like one final one, which is like the evaluation side, which is like I think it's unrealistic to think that like Claude is going to be better than like AlphaGo, which is Google's AI model to play Go. But I think there's a like relatively near future where Claude is able to make an algorithm like AlphaGo that is at the same capabilities, if not better. And I think this is kind of the like if we just abstract further and further and further, these tools will become like more and more useful, and then they can determine and implement deterministic or non-deterministic systems where is appropriate.
Always find it interesting as you're describing these things, Callum, because as you're describing it, what really strikes me is the old way of thinking. Those of us, and I'm looking at Peter and myself in the camera right now, but Peter and myself, like our traditional model of how business is run, how technology is deployed, how we build things, all of these things are really up for grabs in the sense that we've got a lot of kind of experience that becomes less and less relevant as you move into a world where, you know, you've got a system like Claude, an LLM like Claude that can go and go, okay, you want an AlphaGo, we'll build it. You want X, we can go build it. versus where at the moment we're thinking of all the stepping stones and we've got our old framework that we're building at those stepping stones. Not sure there's a question in there so much as an observation and a kind of look back and go, really? This is all the experience I've spent all my years building up suddenly gets less and less valuable as I go forward. Let me turn it into a question, which is, what are the skills that you're looking for when you're bringing people into the team or you're in the organizations? What are the skills which really have value in the world that you're working around?
Like I think like the classic kind of cliche one is like agency to some degree, which is basically like I think things are going to become easier and easier to do technically. And we're going to be able to like do more and more things technically faster. So I think basically like just like going out and doing it and getting the data, like it's just quick to get data. But then B also like very tied into this is basically like, can you figure out which data it makes sense to you? So like really strong prioritization and basically like having blinders on anything that's not what you need to do. So like, I don't know, you don't need to spend a day making graphs that connects. I think like if you get the data and you get the point across, like this is great. And then get the data as fast as possible and go to the place to get the most accurate data you possibly can. And I think like, yeah, just throw the technical together that is required in order to get the information and question you need. And just like answer as many questions as fast as possible and like de-risk things as quickly as possible.
Decision making at speed and prioritization and these things. You realize that's what we've been working on for decades, Dave. Like,
we
just pointing it out. Like,
well, exactly. I was just thinking
to make you feel a little better about yourself.
Critical thinking. I know. I'm feeling just fine, thank you. But yeah.
Yes, there you go. But it's a dark path there.
No. Well, I'm struck with the conversations that we're having all the time, Peter, when we're going into organizations, is where decisions get made. Have they got all the information they have to make the decisions? And I think, Callum, what you're describing is that capacity for critical thinking.
Yeah.
The ability to go and have, well, there's the other part of that is the first part that you had there as well. We were talking about the agency part of it. Yeah. So that's also something that, especially in large organizations, a lot of people have had it beaten out of them. You've now created a set of tools and capabilities that people can take that. People who have that agency can now become gather the information, make decisions, build things, understand and do the analysis themselves much faster without having to rely on other parts of the organization to get that information to them.
And I think like that's a big one to touch on, which is basically like the calculus has changed over how long does it take to implement some sort of technical whatever in order to get this information, and is it worthwhile all of a sudden, right? Like things are getting like extremely quicker to do technically. Then all of a sudden, like debating over 2 hours of whether we should or shouldn't do this is all of a sudden stupid, because what used to take us 2 weeks in this 2-hour conversation was totally worthwhile. Now it takes significantly less time, and therefore like the conversation might just be longer than it is to just like, let's try it out and get back to me. It's like, does it not?
I might regret saying this, but imagine all the stuff you could have got done while you were listening to this podcast.
Yeah.
On that note, I think at this point in our call, as we're wrapping this up, we always like to have at least one thing for our audience to take away, and we have 3 things and one from each of us. So Callum, what would you like as our guest? Would you like our audience to take away from this podcast today?
I think the really interesting one is like it's becoming easier and easier to build more things. So basically like figuring out what to build is kind of never been more important. And then just kind of going and building those things and realizing that like the barriers to build things has never been lower, really.
Yep. Like that, Dave?
I'm going to pull on the thread that we got to right at the end. And first of all, Callum, it's always fascinating listening to what you're up to and what you're seeing around you. So I've really enjoyed the conversation. I'm now going to try and kind of draw the thread out that Peter, you were just touching on, and you and I were discussing, which is around leadership. And what I'm struck with in this conversation is how the role of leadership really moves towards agency, rapid decision making, and interestingly, not being in control and setting the strategy, which is traditionally what a lot of leaders are trying to do, because what we've been discussing here is what's the point when you can go and prove it in the marketplace because you can build it so quickly. There's a really interesting kind of gap there that needs exploring more.
Yeah, I think that's a really good point. It's the inversion of the pyramid, the one that we've been talking about, as I mentioned, for decades. But
Yeah,
I think
absolutely. Yeah.
I think this technology though really is AI is something that really makes it possible to do some of these things which would never been possible before. Which of course doesn't leave me with a lot to take away. Although
We've given you as much agency as we can, Peter.
well, great. Well, I can talk about all sorts of things from there. But anyway. I did like your framing, Callum, of the fact that we can get so much more done in a very short period of time. That means that if we, instead of getting to get everybody together for talk for 2 hours about how we might possibly do this and trying to convince everybody that it should be done, we could be better spending those 2 hours doing it, and and just taking that away as a frame of thought around, okay, how do I put this into production and test it that quickly? Again, Dave, something we've been talking about for years. So it's just now it really becomes possible. I think that's a very good framing of really what we're enabling. So I'd like to thank you very much, Callum. Really enjoyed the conversation, and Dave, as always. So until next time.
Callum, thank you so much. Peter, always a pleasure.
You've been listening to Definitely Maybe Agile, the podcast where your hosts, Peter Maddison and David Sharrock, focus on the art and science of digital, agile, and DevOps at scale.